So finally, one of my favorite discussions, and a lot of people are like, well, wait a second, now we're getting into biology. Remember I talked about at the beginning of the semester, physical science really brings in all of the sciences together and the physics of how the eye works. So you have to know the anatomy of the eye, which is biology, and the biological aspects of the eye. So a lot of people don't understand that when you're studying the physics of the human body, you really have to understand the biology of the human body. So I got this picture of the eye, way more complicated than you'll need to know for this class. So you don't need to know all of these parts, but it was one of the better pictures I could find. And so when you're looking at some things, you're going to go through and kind of check some things out and some of the things that we're used to. So we're used to looking at this. So this part right here is the lens. Okay, I'm not worried about all three parts. We have a lens there, poorly traced. We have the retina back here. Okay, so this part, the cells that are in this part. So the retina here, and that's where image is going to be cast onto the retina. Remember we talked about a real image. So we're wanting the eye, so we're wanting light to come into the eye and be able to cast an image onto the retina for our brain then to, and nerves coming off the eye, the optic nerve right here, sending the information to the brain, and then our brain will interpret that information to create an image in the brain. So it's really cool to go through and kind of look at what's happening here and what type of lens. So let me erase this for a second so you can see the lens a little bit better. So if you look at the lens, it's not a perfect shape, but it looks very converging. Okay, so typically we would have a converging lens here. It's definitely not diverging, so we would have a converging lens. Remember we got the cornea, we have the iris, which you're used to seeing, so that's going to wrap around the eye, the collar part of your eye. So there's a lot of really cool aspects. Like I said, I'm not going to go through all of this. Really cool aspects of the eye, and the eye is a phenomenal thing. The way the eye works is just phenomenal. If you ever studied it, it's just purely amazement. Now here's the deal. Your eye will slowly fall apart. Remember we talked about the second law of thermodynamics with entropy. Things fall apart. When I turned 40, things on the page started getting blurry. I was having frustrations. I write grants. These grants are like 20, 30, 40 pages long. And it was getting blurry. And I was like, what's going on? And so I finally broke down and went to the doctor. And the doctor's comment was, your eyes are wearing out. It comes with age. Now, granted, I was not happy when he said it comes with age, but it's true. My eye was wearing out. Okay, it's not going to improve. So let's look at a couple things with what happens when the eye doesn't work the way it should. And so what I have here on this picture, let's call this picture A, picture B, and picture C. So we're talking about the same pictures here. Picture A is what you want the eye to do. So we'll take the lens away for a second. So you have the eye. I wish I could cover the screen. I tried to do that with my hand just now. So yeah, if you have the eye here and you have your lens, you want light to come in and be focused. So let me change A. Mess you up, I apologize. Let's just call this D. So this is image D. This is what you want. So this is a working eye. You want the lights to focus on the retina, okay? Well, so what happens is one of two things. B could happen or C could happen. So B, which is myopia, is where the focal point is before the retina. So the focal point's in front of the retina, whereas hyperopia is, you'll see the focal point's back here. So these two things can happen. So you want your eye to focus on the retina so that everything works perfect. But what happens is you have one of two things happening, and oftentimes, so farsighted, and so this person can see far away objects, but not up close. This is me. I need reader's glasses. Okay, I cannot see things up close. This is nearsighted. They can see up close, but need glasses to see far away. So these are people who glasses to drive or something like that. So not just reading glasses. So a lot of times the hyperopia, farsightedness, occurs as you get older. Your muscles are weakening and you can't see up close, but you can see far away. And then you'll see kids who can't read the board at school or something like that. They have myopia. Their focal point in their eye is too close. They need glasses, and you'll see from the second picture, from picture A, that you want to, so you're trying to extend, okay? So you're trying to extend and move this focal point back. So you're trying to lengthen the focal point, okay? So if you remember in the previous lecture, when converging lenses takes light and bends it in, but the diverging lenses take light and spread them out. So what you want to do is you want to be able to spread that light out a little bit to extend the focal point. So you would have ideally a diverging lens here. Now, we're not going to create glasses like that. You're not going to see that particular type of glasses, but that's ideally what's happening. And here, for the hyperopia, I need to bring this focal point back in. So I need to put a converging lens in front of the glasses, in front of the eye. Now let's use this for example. This would be super uncomfortable. I do not have contacts. I only wear reading glasses. But if you have contacts, I don't know if you can imagine putting this on your eye and actually being comfortable with that. Okay, you want, put in a different color, you want your contacts to fit over your cornea. Okay, and that's where I was talking about in the last lecture. You're going to have glasses with different rays, so each of the side of the lenses and each of the side of the contacts will have different radii to go through and actually give you the same concept as here. You're not going to use a pure diverging lens or a pure converging lens to get the effects. You're going to use a combination of, just because, especially when it comes to contacts. I can't imagine putting this onto your eye. Just this part right here would be rubbing against your eyelids, and just that irritation would be like sand in your eyes. So just the physical structure of the lenses do not lead to a wise choice for the glasses and contacts, but they gave the eye doctors and scientists a basis of where to start. I know my dad used to work for Bausch & Lomb, and he would bring the glasses. Now this was back when I was a kid, so way before most of you even thought about, and the glasses used to be super thick. They used to make eyeglasses with glass, and they were super heavy and super thick. And so you would actually have these glasses, and you could feel the different wavelengths on the different sides. Now the glasses have gotten much smaller. They use different materials. They use plastics and polymers. So you can't necessarily feel the different wavelengths. They're not as obvious. But it's still kind of cool. So what we're going to do in the next video is we're going to go through and look at some equations. We're going to look at the equations called Lensmaker equation. What do these eye doctors use without telling you, to find out what is your focal length of your eye and how to adjust it, and then just the basic focal length equation on how to find these equations. So I want to introduce two aspects of the eye. I'm not going to talk about astigmatism and stuff like that. It gets too complicated. Well, here, let me just kind of pop that in there. Normally you would want your lens to be round, but what happens if your lens, and I'm exaggerating, is more oval? So it's not focusing evenly onto the retina. So you get astigmatism where you get some blurriness to one side. And I'm exaggerating this astigmatism, but I know I have a slight astigmatism in one eye. I have problems driving at night because the glare is very blurry to me. So I use polarized sunglasses in the day. And I'll be very honest, as crazy as it sounds, at night, especially if it's raining, I'll use my polarized sunglasses if I'm driving in the city, because I can still see with the city lights, to cut down the glare off the road when it's raining. I know typically, personally, I prefer not to drive at night in the rain just because I can't see with the astigmatism, that glare. And that's what the polarized sunglasses are for, is to minimize the glare. Fishermen use it. Boaters use it to minimize the glare coming off the sun. And so they're really a neat phenomenon when it comes to sunglasses for a person that has astigmatism. I know they make glasses, regular glasses, and they put a film on it, like a polarizing film that's clear, for regular glasses to help cut down the glare as well. So again, astigmatism, I'm not going to go into great detail. Myopia, hyperopia, nearsighted versus farsighted. A lot of you probably have this, or one, or maybe both. And I'll just be very honest. As you get older, I'm sorry, the muscles around your eyes are going to weaken just like everything else. Welcome to entropy, and you'll probably, I hope not, we're willing not, but there's a high possibility that you will eventually go into the farsightedness world as well.